Now is to present the other large-scale TID forecasting model we developed in the framework of this project, and then some validation case events we selected among the ones we investigated during the validation processes we did for both of the model. So just to give you some, not so much, but some details about the model. This is what we used as features. So as input of our model, we use ionospheric data, geomagnetic data, solar wind, and solar parameter like solar flux and solar zenith angle. For the ionospheric data, as Anna said, we rely basically on HF data, so HF interferometry. But in the case of what we called catalog-based model, so this model, we rely on a catalog that was developed by the colleagues from Ebro Observatory. That is an handmade catalog by looking at the results of the HF interferometry. So for each case events, for each of the map you can see here, there was a colleague looking at the map saying, okay, this is a large-scale TID, this is not. So the catalog collect more than 1,600 large-scale TID events between 2014 and 2022. So we use this catalog as our ground truth in order to train our model. So catalog-based model, the forecasting horizon is within 3 hours. So what we are saying here is if the large-scale TID is going to happen in the next 3 hours or not. And it's a European-wide forecasting. So just one yes or no for all the European region. The model is based on CATBoost. That stands for categorical boosting. So it's a gradient boosting algorithm based on decision tree. Actually, a lot of decision tree that we called weak learner. So for each tree, we train each tree after the other in order to minimize the loss function. The advantages of this kind of algorithm is that it's computationally very efficient. That it can manage the categorical variables and missing values natively. And then we can rely on the SHAP values. SHAP is a tool of what we call explainable AI. So it's a tool that allow us to look into the details of the decision that the algorithm is gonna give you. So you can see each of the parameter, how each the parameter force the model for a higher or lower value as output. And this is particularly, let's say, useful during the validation process or to evaluate the quality of the output of the model. So at the end, we came up with 3 different operational modes. So high precision, balanced, and high sensitivity of the model. The user basically can select the different operational mode. The first one, the high precision, is the one to be selected when the user has an high cost for the false positive. So if you want to minimize the false positive, you should select the high precision operational mode for the model. On the other hand, the high sensitivity is the one you should select when the high cost is on the false negative. So here we are minimizing the false negative. I hope you are familiar with this confusion matrix here to, show the false positive, false negative, and true positive, true negative. And these are the results we obtain in terms of precision recall and F1 score with the 3 different operational mode. But let's go to the web app that we developed in order to demonstrate. Of course, it's a demonstrator. It's not an operational tool. It's a demonstrator we developed in order to, let's say, demonstrate the capabilities of our web interface. Okay, here we go. This is the home page of the web app, giving you some basic information about the model, about the project, about the data we are using for the model. But then if you click here, machine learning model, you can get this interface from which you can select the different features you want to visualize on the web app. So to be clear, the model always use all the features we used for the training, but you can select 5 of them to be shown in the web app. And then you can select the model out, the operational mode you want as output. Here we have the high precision and balance prediction. You can select here a time period. You can move this slider here to obtain the let's say the model evaluation, and then you can you can get different information here. So the ground truth, that is basically the information given by the catalog. Then the high precision and balance prediction. Here you can see it's always basically 0 or 1. That means no or yes in the next 3 hours. And you can see here, for example, the difference between the 2 operational mode. So in the high precision, we are minimizing the false positive. So there's some events detected in the balanced option that are not in the high precision prediction. And then here you get the features you have selected at the very beginning to be shown here together with the prediction. So basically you can see if something is going on during the period you selected in terms of geomagnetic storm or auroral indices, basically. So this is how the web app works. Of course, again, it's just a demonstrator, but it's very useful to, demonstrate the capabilities of the model and to check also for us the capability of the model and the goodness of the output of the model. So going back to the presentation, here I'm gonna show the validation on 4 particular case events. Actually, during the validation process, we selected 15 events. Not all of them are common for the 2 different large-scale TID models. So these 4 events are among the 10 common case events between the 2 different models that here we indicated like CB, so catalog-based, and SB, so SEC-based. So the one on the left is the one I just presented, and the other one is the one that Kostas presented. So here basically what we have is the date of the events we selected, the response of the catalog. So basically the ground truth, if there are there was a large scale TID or not in that particular period. Then what you can say looking at the drivers. So here is the human looking at the SMR, auroral indices, and other features, saying, okay, to me this is a large scale TID and this is not. And here the output of the 2 different models for the 4 case events. So let's go through very quickly through the case events. This is the first one in 2022. And these are the output of the 2 models. Sorry, but it's not very clear here. But if you look at your PC, if you are connected on the Zoom, you can see here that the ground truth says that basically there are large-scale TID between 4 p.m. and 10 p.m. on 13, and during the night between 13 and 14. And the output of the models can, catch quite well the behavior of the large-scale forecasting in these particular days. What we did for validation, we look at basically independent data or independent way to process the data. So here you have some example on what we did for each of the case events. So in the upper left, you have quite complicated plots that is based on the radio link between Pruonise and Julius Roux. This is again an HF way. It's from HF data. It's a way to look at the TID. So here, basically, the dots are representing the azimuth of the TID. You can see here in the right y-axis, and the bar represent the amplitude of the TID, with the color representing the period of the TID. So here, Chan is representing a longer period, while purple is the shorter period. Okay, so as you can see here, around 9 p.m., you have this quite visible TID activity that are in the catalog here. This is an example of the results of the HF interferometry. The colleagues in Ebro looked at to say, okay, yes or no for the TID on the catalog. Then here you have an example of the isodensity plot you can build looking at the different ionosonts. And again, around 21, so 9 p.m., you have this huge wave activity here that we recognize as large-scale TID. And independent data this time, the kilogram based on the trended TEC. Sorry for the color, but there's a yellow box here representing the time period we are considering. And as you can see, we have here clear strips representing large-scale TID here. To be honest, there's something even before, but we are, focused on this time period in which the strips are quite well parallel and quite well visible. So we are quite sure that here the trended TEC is saying that there are large-scale TID ongoing. We did the same exercise for the other case events. The case events we selected are not necessarily the best ones. So to be honest, this is something that is gonna show you that the models works, but has some weaknesses as well. So the model can be for sure improved, and this is what we are still doing, even if the project is close to the end. So again, another day in 22. This is July, and again the catalog say yes. The human looking at the driver say yes, and the two model agree on saying that okay, there's a large scale TID ongoing. Again, here, trust me, there's something for both the high precision and balance model, and the SEC-based model give us some good forecasting in Ebro Observatory and some, let's say, hard to be interpreted in Chopron, but this is something, it could happen. So as I said, the model are not perfect. Again, the validation. So again, here you can see that looking at the HF-TID methods, we can get something around midnight with a, let's say, short period. It's a large-scale TID, but it's shorter than the one I have shown before. And this is why probably there's basically nothing in the kilogram looking at the TEC, because the period is shorter. So depending on the filter or on the, let's say, time window you selected to the trend TEC, you can miss something that is shorter than you expected. And then hard to see activity here also in the ISO density level from the ionoson. So this is a case in which, okay, we have large scale TIDs. The model perform quite good, not perfectly, but even looking at other data, we are not 100% sure that large scale TID are there. So this is why we put these case events here to be shown. Again, this is another interesting case events. So here the ground truth is no. So the catalog is saying the Ebro colleagues said there's no large scale TID ongoing, looking at the HF interferometry, but the models say yes. And looking at the driver, seems that something is going on. So here again, you can see the output of the models, the catalog-based and SEC-based model. Again, the prediction seems to be quite well in agreement with the SEC measured in Ebro and Sopron. But I mean, looking at the data again here, unfortunately, we missed the radio link between Pruonis and Julius Roux, so we have the HF TID plot I have shown before. Here we have some example of the HF interferometry that, I mean, it seems to, in this particular case, it seems to be, I mean, quite clear that large scale are there, but probably what happened is that this is a particular shot of a particular time. So looking before or after this image, probably you are not sure that large scale TID is happening. So this is why the Ebro colleagues said no in the catalog. Even in the kilogram here is not clear if something is going on or not in this yellow box here. That is the period we are considering. And looking at the iso density, I mean, it seems that some TIDs, some wave-like activity are there, but we are not sure. So this is a case event. We cannot say, okay, the model, I mean, the model is performing quite well, but we are not sure actually if large-scale TID is happening or not. Last case events, again, this is something that it's in the catalog. The model was, one of the model was able to predict. So the SEC-based model is able to predict, while the catalog-based model said no. But looking at the drivers, we cannot see any signature of geomagnetic activity ongoing. So what happened? Again, we don't have the radio link here. Looking at the HF interferometry, I mean, again, we are not sure. So the Ebro colleague said no. And actually looking at the other validation data, I mean, we cannot say their large-scale TID are there. So probably the catalog is right. One of the model is right. But again, this is a case in the middle. So we are not sure actually ourselves if the large-scale TID is happening or not. So summary and future steps. We developed, as you have seen, 2 different AI-based model for large-scale TID forecasting, so catalog-based model and SEC-based model. One of the model gives you one single forecasting for all the European region, while the other one is giving you forecasting based on single ionosons. So the 2 models work quite well together. And the time horizon is slightly different. We developed the first version of the demonstrator for both the model, and we performed a quite extensive validation on a statistical based and on case events based, as I said. Future step, at least for the model, for the catalog-based model, is we are in the process of calibrating the model. So actually, what the model is giving you as output is a number. Then you can set the threshold to say, okay, below the threshold is no, above the threshold is yes. But with this calibration process, that is not an easy task, actually, you can get a probability. So the output will be a probabilistic forecasting, not only a classification forecasting. And then we prepared actually the trended TC catalog in order to integrate the catalog of large-scale TID that Ebro colleagues provided in order to be, I mean, more accurate in saying, okay, we have large-scale TID or not. And this is all from my side.